Welcome to Python Basics with AJD. In this video, we'll be looking at introduction to Python packages. So for the next set of videos, maybe up to 10, 15 videos, I'm not sure, I'll be looking at Python packages in general. So what do we need to know about Python packages? Python power Python's power comes from its modular structure. So you can have modules in Python like that. So instead of writing everything from scratch, we can reuse and organize code using modules, packages, and libraries. So we have modules, packages, and libraries, and that is what we call the modular structure. And that's why in working with Python, you don't have to write some things from the scratch because there are modules, packages, and libraries that have been made available to take care of those things. So in this lesson, we'll cover what modules, packages, and libraries are, difference between built-in modules and third-party party packages, and we'll understand namespaces and imports. So first off, what is a module? What is a module? Simply, a module is a single Python file. So it's a module is a simple single Python file with a .py ending containing reusable code, functions, classes, or variables that have been predefined, right? An example is Python's built-in math mode. All right. So, and how do you create and use a simple module? Okay, imagine if I want to write a simple module to just greet anyone that interfaces with it. So I have this double percent write file, and then the name of the module is my underscore module.py, and then so the module is just a function that says hello, whatever, and once you supply your name. So in this case, I just say, so I define the module here by just running this. So it's a function defined. The name of the function is greet. It takes the argument name and it returns hello for the whatever name is supplied. So if I run this now, that's okay. Of course, the first time we're running, it takes a bit of time. This one is taking so much time. Okay, yeah, we have it. So we have the module done. So now that the module is taken care of, so you can then call the module just like what we as you're going to see using the module now. So you have created the module now. I want to use the module. So the first thing you want to do is to import the module called my underscore module. Then after that, you can then print. So from my module, you call the greet function, right? And then you supply a name. So let me say this time around, the name is Jesuyon. So if I run this now, then it says, hello, Jesuyon. You can change that, of course, and say, hello, Adeshewa, right? Hello, Adeshewa. Like that. Okay. So that's us calling the module. So normally, most of the modules we've been using, you don't see the source code, but this is a typical way the source code will look like. Though this is a very simple module that is greeting whatever name is supplied. So we talked about modules, packages, and libraries, right? So next, the question is, what is a package? So if a module is a file, a package is a folder, right? Containing several files, several modules. So a package is a directory or folder containing multiple modules. So it must include a double underscore init double underscore .py file to tell Python it's a package, right? So when you have a .py file, that's a module. And when you have a double underscore init double underscore .py, then it's a collection of modules being a package, right? So an example structure is this. So you have my package slash init like this. So normally I think it should be double underscore init double underscore py, then .py, and then you have module one, module two. So assuming we have two modules here. So a very good example of this would be the NumPy. So NumPy is actually a package, or we always like to call it a library. So those I've been using those words interchangeably so far. So an example will be NumPy, which has sub-modules like NumPy.linalg, NumPy.random. Now, if you follow my the playlist on scientific computing, I went through NumPy a lot. So I took the different submodules in NumPy. I worked with them, explained how they operate and things like that. Okay. So imagine me now trying to create a package. So I want to create a simple package structure with multiple modules, with just two modules, in fact. So we need to do exclamation mkdir salutation. So the name of my package is salutation. Then we now have touch salutation double underscore in double underscore py to show that we have more than one module in this case. Okay, so exclamation echo. So here we define a package called greets. All right, and what it returns is it says hello from my salutation, and then the name of that is salutation backslash package underscore module. So this particular package now, so this particular one, you have the name of the package is salutation. So one of the module under it is package underscore module. Then we have another one. We have defined another greet name. Return hello from another module in my salutation. So that is what that module is doing. And the name of this module now is another module, also in the package salutation. So in the salutation package, we have the in the salutation package, we have the package module, and we have another module as under those packages. So of course, you don't want to forget to run that. So that's been run. So they have been committed. So once that is done, then we can go ahead and use the package. So imagine, so you see that if you want to call a particular module from a package, then you say from the package. So from salutation, import package underscore module. That's the first module, and then you now print. So from that, you have package underscore module dot package greet. Package greet will just say hello from my salutation, right? Then okay, I can even move this to the next cell, right? I will use alternate enter to create another cell automatically. So here now we expect that this one will just tell us hello from my salutation. We run that. So that's done. Okay, yeah. So then for this now, I have, so from the same package called salutation, we import another module. All right. So we import another module, and then we now print another underscore module. From that, we call the package. From that package, from that module, we now call the function another underscore greets, which will say hello from another module in my salutation, right? Something like this. So we can have multiple. So when you have multiple modules, it becomes like a package. So we go ahead to the idea of a library. So Python is modular in that it is layered in modules. Then a module being a file. When you accumulate two or more files of a module like that, you have a package. And then talking about library now, a library is a collection of packages and modules designed for broader functionality. So for instance, NumPy, for instance, does numerical computing. Then Pandas does data analysis, and it is built on top of NumPy. Matplotlib does data visualization. So you see, we create a set of functions and packages that does numerical computing, and we aggregate all of them together, and that is NumPy. So if you're a professional in a particular field, let's say you are any field you're in, maybe you're an architect. So you can have something like ArcPy. I don't know. I don't know if there's something like that already. So you can have ArcPy, and then you write a set of modules and packages that does architectural stuff like that. All right. So in summary, we see that a module is a single .py file, and a package is a collection of modules, which is a folder, and a library is a collection of packages. So a collection of modules is a package, a collection of packages is a library. That is the modularity of Python as a language. So then we talk about built-in modules versus third-party packages. So built-in modules, of course, as the name implies, they actually come with Python standard library. So they are automatically on the Python library. Then no installation is needed in this case, right? So there's a standard Python library, right? So these built-in modules are automatically found there. So you don't need to install them because they are built-in. Example is math, that's the math module, the OS, that's the operating system module, the random module, and the date time module. They are all built in Python. Then you have third-party packages. So third-party packages are actually created by the Python community. So like all the NumPy, Pandas, Request, Matplotlib, Seaborn, and so on and so forth. They are created by the Python community. So I could also create a package like that, and then that would be my contribution to the whole place. Of course, that would have been tested before before it's made popular. popular. So it is created by the Python community. And in this case, built-in package modules do not require installation because they are built-in, but third-party packages require installation using PIP. So examples are NumPy, Pandas, Request, and Matplotlib. So let's see some examples. For instance, for built-in module, if you want to use the math module, for instance, you discover that normally you cannot do some mathematical calculations if you do not call the relevant module. For instance, if you want to look for square roots, you can't just find square root like that. You have to import math, and it is inside the math module that you can find the square root function. For instance, you have to import math, so you can now print from math. Now you need the square root function, so you can now find the square root of 25, which will give you 5. And then from math function, you need pi, which is 3.142 and so on and so forth. So if you run this now, you can get 5.0 and 3. All this like that. So that is built-in module, and you don't have to install it. On the other hand, if you have to use a third-party package like NumPy, okay? So for a third-party package like NumPy, so you need to install with pip before you use. So if you're using, of course, I've used NumPy a lot of times on this computer, but let's assume that this is the first time I want to use it. So I have to install it, and you just say pip install NumPy. So whatever you want to install, you just say pip install NumPy, pip install Pandas, pip install Matplotlib, pip install whatever. So, and once that is done, it tells you requirement already satisfied, because this is not my first time of installing NumPy. So requirements already satisfied. So if you are doing yours for the first time, it is going to have maybe more lines of reports, or it's going to take a bit longer, right? So now pip is NumPy is there. So now if you're using a third-party package, you have to install first of all. Then after you've installed once, as far as they're using the same device, you don't have to install again. But each time you need to use it, you need to import it. So there's installation and there is importation, right? Installation is for you to put the package on your device. Importation is to open the package in whatever module you're working in, where it is necessarily where it is needed, right? So you have to. So first of all, you install with pip before use, and after you've installed, then you have to import. And to import, just do something simple. Import NumPy, just like we imported math here. So you import NumPy too. So of course, for built-in modules, you don't have to install, but you have to import. You have to import every module, every package, like every library. So import NumPy, and part of what NumPy does is it deals with array a lot. In fact, if you're looking for one word for NumPy about what it does, it's basically about array. So if you need to work with an array, all right, like here now we are turning a Python list into a NumPy array. So in that case, now we have the variable name ARR, and we say NumPy.array because the array function is inside NumPy. So we have to, and that's why after importing, you have to now say NumPy.array, and then you have 1, 2, 3, 4. So, and next thing you want to now multiply each element of the array by 2. So you just print ARR by 2. So you're going to get each one multiplied by 2, 1 times 2, 2, 2 times 2, 4, 3 times 2, 6, 4 times 2, 8, and so on and so forth. So you have 2, 4, 6, 8. Then we talk about understanding namespaces now. So next thing, a namespace is a container that maps names or identifiers to objects. So they map identifiers to objects, and they prevent conflict between variable names and functions. Imagine if we say variable x now in your code won't interfere with math.sqrt. For instance, if you import math and you have x is equal to 10, then you now print value of x is this x. So that's going to print 10. All right. So this is going to print 10. So here you now say print square root of x. And then you now say math.square root of x. So that'll be square root of 10, of course. That'll be like 3 point something something. So if we run this now, we get value of x is 10 and square root of x is 3.1622 blah blah. So the variable x here now does not interfere with the math.sqrt. So no problems at all. That's talking about namespace. Now we go for import statement. We talked about importation not quite long. There are different types of importing. So different ways to import modules. We have the basic import where you just say import maths, and then you can now from maths now you can now print pi. All right, because if you try to print pi by itself, you are going nowhere, right? Because pi does not exist. It says name pi not defined because pi is a function that is only accessible from the math module, right? So that is basic import. And then we can have selective import. So selective import simply talks about you importing specific functions you want from the module. That's selective import. So from math module, for instance, you want to import square root and pi in particular. There are many other things it can do, but you're just interested in square root and pi. So in this case, now you now want to print the square root of 16 and also this and also pi itself. So you run this now. So if you can't because you have specified what you want, you can't do maybe cube or anything here this time around because you have imported exactly what you want, right? So just like the module I selected, I created the package I created, right? If I say, I said from math import. So if I want only one, I mean from salutation import import uh import package module, right? So in that case, another module is not available in that situation because I've strictly requested for that, right? So we have alias import. This is very important. Alias import actually helps you to start to not have to write. The first time we imported NumPy here, you discover that anytime we need to use NumPy somewhere, like when we wanted to use NumPy array from NumPy, we had to say NumPy.array. So if it was longer than this, like matplotlib.pyplots dot something, that's a lot. But to avoid having to write it out each time, so we can do an alias import. So you just say import NumPy as NP. All right. So instead of having to say print and numpy.array, because you have said numpy should be NP, so Python will recognize it and say print np.array, and then it does exactly the same job that like you would have done using numpy directly. So you're importing numpy as NP, right? So that it helps to make you not to have to type the library or the package name every time. That's what aliases are meant for, right? So imagine if I have to do a few more. So let's say now I still want to I want to print what else? Say I want to print, okay, I want the mean of this now. So I just tab this. So normally I should have to keep typing, I should have to keep typing and numpy.mean, numpy.this. So all these things now. I still want to print something. I need the median, okay? So if I need the median of this, maybe I still need something else. So imagine I would have had to write numpy dot all of these things all the way. Okay. So uh like that. So this now, so for this, I just need to do np.mean, np.median, np.std. But if I did not import this as alias, I would have had to write numpy.array, numpy.mean, numpy.median, numpy.std. Numpy is even a standard deviation. Numpy is even short, right? So, but what if you have something long like matplotlib.pyplot.plt, matplotlib.pyplot dot axis, and all of these things. Okay. Then we have the wildcard import. That's more like from math imports, whatever. This is highly not recommended, right? So you want to avoid this as much as possible. It has no special use case per se. So it's more like you're saying from math import, whatever. So there's no need for that when you can just say when you can just say import math and you're good. So some best practices when it comes to using uh, modules, library packages, and libraries. So some best practices, you have to use aliases for readability. Like I said, use aliases for readability, like import numpy as np, all right, or import matplotlib.pyplot as PLT instead of having to write that long thing every time, or import pandas as PD. Now, I mean, it's not compulsory that you must always import numpy as NP. You can import numpy as NU, you can import it as NN, you can import it as NY. It doesn't have to be NP, but NP feels like NP is the most common alias, but that does not mean it's a law. You can choose anything. The only thing is, anytime you need numpy, if you're using NY, for instance, just say NY dot array instead of NP dot array. Then import only what you need. So from math, import square roots. So if you are sure you don't need more than square roots, so you can go specifically for that thing. So that will help you. That will help you to work faster instead of having to say. So in that case now, if you have done square root, if you import square root directly, you don't have to say math dot square roots. You can just use square roots straight up, right? So if you know you are going to use exactly square roots, you don't have to You can just import it and then make your work easier. Then as much as possible, you want to avoid from something import start. That's wildcard import. Like that the one we saw the other time, it's highly not recommended. Avoid that as much as possible. And then by way of recap now, we see here that a module is a single .py file, and a package is a folder containing two or more modules. A library is a collection of packages, and then we have built-in modules. They are part of the Python automatically, e.g. math or OS. Then third-party packages, they are installed separately using pip, e.g. NumPy, Pandas, Seaborn, and so on. Matplotlib also. Namespaces prevent name conflicts, and then imports allow code reuse in different ways, like we have seen already. So with this, we come to the very end of this interesting video about introduction to Python packages. Let me know how helpful this is for you. And if there's something you'd like me to try, feel very free to let me know. All right. So if you have subscribed already, thank you so much. If you haven't subscribed, please go ahead and subscribe. Hit the notification bell so you can always get alerted each time a new video is released. Of course, you can take it a step further by clicking on join so you can become a member of the channel, and that gives you some special privileges like being a member. At the highest level, you can even have a one-on-one hangout with me on maybe data science or whatever, anything I do on this channel, right? Yeah, so that's the idea. Ultimately, don't forget to like, share, comment so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.